Okay, so we know where our primers go, and we know that this our PCR product is 303 base pairs in length. Now what? Now what can you do, right? So, well, let's think about this. What are we interested in this region? Well, we're gonna do a restriction digest, right? We're gonna see if your taster, if you have the taster genotype, if the restriction digest cuts your DNA. Now, where is this thing going to cut? Well, we also know from our pre-lab homeworks and our lab manual and the announcement that was recently posted that the mutation we're looking for, actually, let's look at that bright space, right? It's this one right here. Understand we're evaluating the SNP at amino acid position 262, right? That goes from alanine to valine. All right, so this is what we're interested in. Now, there's several ways to get to this information, right? There's one way you can actually copy this entire translated sequence. I think there's a way to do it in Benchling. So we can go here all the way down, right? And then we have all the amino acids. Let me see if there's a way. Can there click copy? And then, yeah, there actually is a way to do that, right? You can copy the amino acid translation. There's also another way we can do that, right? How is that? Well, if you remember the last video, right, we have this website, right? Again, we just go back, right? So if you search for the gene, right, you get to the gene page, you go down to the RefSeq information, right? There's the genomic. Remember, we got the GenBank file for APE. Now, next, we can get protein information, right? We can click here, right? Just in case you never know what's going on Benchling, right? You can go down. Here's the sequence. Now you can copy paste it from here, right? Or since it already has numbers, you can just do a little count, sanity check, right? So 262, right? This is 241, 42, 43, 44, 45, 46, 47, 48, 49, 50, right? So if this is 50, this is has to be 60, 61, 62, right? So it's around here, right? So let's look at this in benchling, right? Let's remember it's AAFIS or AAFIS, right? So let's go back to benchling real quick, and then we're gonna look in our region, right? And we're gonna look just at this track here, and we're looking for AAFIS, right? Da 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 da. A no. F. Where is this thing? Oh, AA. FIS, AAFIS, right? So we're here. So, oh, well, how do I know which one of these two it is? Well, we know from our homework, and it's over here as well, bright space, right? Let's see, did I write this thing down? Yes, yes, yes. So the codon, right? So this is the general wild type, your taster, GCT, right? And the mutation becomes non-taster to a valine, right? So GCT, that's what we're looking for. So let's go back. Let's go back. G, and then we are here in this region, GCC, GCT, and we know the mutant copy, the non-taster, gets GTT, okay? So now we know this is the amino acid that's changing. So let's create another annotation, right? This time we can call this the A262V, substitution. And just for clarity, right, we can also write here, it goes from C, because that's what we see in the sequence, to um, C to a T, right? So GCT to GTT. Maybe that's not clear. Let's add some spaces. And then we can save this. And actually, there's no strand, right? So none. Can make this another color. Let's make it stand out. And then boom, here's our little annotation, right? Here's our little annotation. Now, we know that another question was how much are the pieces, expected sizes, if you do a digest and you're either homozygous, recessive, homozygous dominant, heterozygote, what are you going to see on the gel? So let's have a look. And we're in this region here, right? So we're going to highlight this. And also what's really cool about benchling, and I think APE as well, has this little pair of scissors here. It doesn't really work too well on benchling, but let's try it anyway, right? I already found the enzyme. Here it is. You can search for our enzyme of interest, and it says, hey, listen, lets us know where it makes the cut, right? Pretty cool. So it's going to cut GCN, GCN, right? So it's going to cut the wild type taster allele. Okay, so then also you can jump to cut sites, and now you can drop down and say, listen, I want to cut site anywhere in the sequence, anywhere in the current selection, or only in the current selection. And usually this thing is not really working well. So it must not be working well in other places because I see here that if anywhere in the sequence, right, you get 6. A lot of people put that for their homework answers, 6, right? And these are the 6. Again, you always have to check, right? Don't always just go willy-nilly. Oh, I'm going to believe this. Let's have a look, right? So if we jump to cut site, we can use this tool here. We can jump to this cut site, move this. It's outside of our sequence of interest, right? It's outside of our sequence of interest. We're going to the next one. See where this is at. Outside our sequence of interest again, right? Let's go back and then go here. Uh-oh, we're in here. Let's see. Look at that. It's right where we need to be. Right where we need to be. Well, let's see. That was this one. Was it this one? I think it was this one. Yes. And then this one, let's look at where this is at. It's outside of our sequence of interest. So there's one cut site right here, right? Right about there. Boom, right? And I think it's this guy, the 870. And also it has a nice little button here to run digest, but I don't think it works. So I tried it earlier. Let's see. Okay, let's select here just so we could run this through because, you know, I gotta make sure. All right, we're gonna cut and we're gonna do only in the current selection. See if this works. I'm gonna run the digest. And it brings you here. Yeah, it's cutting the entire sequence, right? 6 cuts. And if it worked, it would be nice because it would have a mock gel for you and you can pick your ladder, right? Pretty cool, huh? Pretty cool tool. This ladder we use here, right? So pretty cool. But this is incorrect, right? This is incorrect. But as long as you know what's going on, you can pick things like this up. Maybe I should write these guys an email. Let's see if they can fix that up, right? Because it could throw people off. Okay, so we're getting rid of the digest, but we know it cuts here. And so now what we can do is we can drag and we can begin to measure, right? Here, if the enzyme comes, remember, just let's use our imagination, right? A linear piece of DNA or product goes from here to here. You got an enzyme that's going to come and make a cut right around here, right? And then this length, right, you're going to get a piece that's 64 base pairs. And then we can go, remember it's cutting a linear piece of DNA. You're going to get another piece here that's about 239 base pairs. Would you look at that?